We are continuing our review of the Mod 1 learning targets, and we are going to go over page 4 and 5. So we are creating tables, creating graphs, we're working on our scale, and we are creating explicit and recursive functions. Here we go. Let's look at problem number 29. All right, in 29, we've got some growing squares. So what I'm noticing in figure 1 is that I have 3 squares. Figure 2, I'm noticing that I have 6 squares. I kind of see them as these blocks of 3 here. See that? So I see I have 9. So I am guessing that I'm going to have 12 squares. Okay, so if I wanted to put this in a table, I would say this, I would have my figure here, and then the number of squares. We always want to think about scale, so I'm going to start at 0. Now these numbers are relatively small, so I think I am safe just going by ones. That was a 5. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Plot my points. So for figure 1, I am at 3. Figure 2, 6. Figure 3, 9. Figure 4, 12. All right, so is this geometric or arithmetic? I see that it's linear. I see that I am increasing by 3 every time, so I'm going to go with arithmetic. All right, so if I wanted to write, I like to start with the recursive formula. So I know my first term, in the first figure, I've got 3 boxes. Then, to find any term in the sequence, I take the previous term and I'm going to add 3. All right, explicit. So my explicit function, I know that I am starting with 3. And I have 3, then I have 3 plus 3, then I have 3 plus 3 plus 3. And then, so what do I really have? I have 3 plus 3 times 1. I have 3 plus 3 times 2. This I have 3 plus 3 times 0. So I am starting with 3, and every time I'm repeatedly adding 3. And the question is, how many times? Well, what I notice is the amount of times I add 3 is 1 less than the figure that I'm in. So this is going to become n minus 1. Number 30, looking at the table, I'm noticing for each scenario, 1, 2, 3, and 4, my y values are decreasing. And it appears that they are being cut in half. So we're saying we're multiplying by 1/2. So my recursive formula, start with the first term, and then I can say my previous term, f of n minus 1, is being multiplied by 1/2 every time. All right. Now, if I wanted to break that down with the explicit formula, I would start with 18, then 18 times 1/2, then 18 times 1/2 times 1/2, 18 times 1/2 times 1/2 times 1/2. So this would be 18 times 1/2 to the first power, 18 times 1/2 to the second power, 18 times 1/2 to the third power. So if you see the pattern, the explicit formula is going to be 18 times 1/2 to the I'm using x, x, but notice how the exponent is 1 less than the term. So this is term 1, this is term 2, term 3, term 4. So that means this is going to be x minus 1. Next example. All right, we have Margaret. Margaret has $70 to spend at the carnival, and each ride that she goes on costs $3. So the amount of money she has depends on how many rides. So I'm going to label my table number of rides and then the amount of money she has. So if Margaret goes on 0 rides, she's going to have $70. Every ride she goes on is going to cost her $3. So I know the amount of money she has is going to go down. So if she goes on 1 ride that costs $3, she now only has $67. She goes on 2 rides, that's going to cost her another $3, $64. 3 rides is going to cost her another $3, and so on. So the recursive formula would tell us f of 0 is 70. And to find any term, we would take our previous term, f of n minus 1, and we're going to subtract 3. So we keep subtracting 3 every time. Now, when we look at what this means with the explicit, we start with 70, then we do 70 minus 3, then we do 70 minus 3 minus 3, 70 minus 3 minus 3 minus 3. And what I notice here for my function is I always start with 70, and I'm always repeatedly subtracting 3. But how many times? And for this example, because we started at 0, we are subtracting 3 the same amount as what the term is. So this would just be n. It would not be n minus 1. All right, last but not least, number 32. Now what we need to do is we need to look at this graph. And I think, honestly, it would be helpful for me to see this as a table. So I am going to make a table. So I look at 1, I'm at 2. At 2, my y value is 4. At 3, my y value is at 4, 5, 6, 7, 8. Now I feel like I can see the pattern. I am noticing that, 1, I notice it's exponential because it's increasing quickly. So I know I'm going to have a common ratio. And then what I notice is I'm multiplying by 2. All right, so my recursive is saying my first term, f of 1, is at 2. To find any term, I'm going to take my previous term and I'm going to multiply it by 2. All right, so for my explicit, to close this up, let's look. I'm starting with 2. Then I have 2 times 2. Then I have 2 times 2 times 2. So you may see here that all I do is I just keep multiplying by 2. And how many times? The same as the term number. Another way to look at this is I have 2 times 2 because I have my original number, and I keep multiplying by 2 to the n minus 1.